Hello, everyone. Welcome to my talk. Hopefully, you all know what is AWS, because that's what you're going to hear a lot today. I will just take some of your attention, and we'll talk about Terraform and some serverless. So, my name is Anton Babenko. I've been doing AWS and Terraform since 2015, and I've been doing it so actively that AWS decided to give me a title, which is AWS Community Hero. So, okay. And okay. And during this period, I was thinking about open source, and I just like to solve problems which I have for different kind of customers and for my own projects, and then release them as open source. This is pretty much how I got into Terraform AWS modules. Some of you probably know what is it. Some of you maybe use it. Raise your hand if you use it or you know it. Oh my God, that's good. All right, so then the rest of the talk is not needed. You guys already know what is it. So then I made pre-commit Terraform hooks because I decided that it's a good idea to have clean code and documented it so that we focus a little bit more on how this code is actually written and so on. And then when COVID started, I realized that there is pretty much no easy solution to do serverless on AWS. So I looked into existing solutions, figure out what is the problem, what do we want to do with this if we use Terraform. And that's how I started with serverless TF project. And then also a bit later, again, I was sitting at home and figured out that what can possibly go wrong if I decide to live stream every Friday. So I had more than 100 live streams since that time where I'm doing some Terraform activities, like reviewing different things or talking to different developers and answering different questions from people. Or just live coding. So if you want to learn more about how Terraform modules are written and why they are written this way, feel free to join. And also, Weekly TF is my weekly newsletter, which I publish every Wednesday. So this is how a newsletter looks like. There are at least 5 different articles every Wednesday, plus some open source projects which I find useful. So feel free to subscribe and share with your colleagues because I think it's pretty good amount of information published. So we need to just share it. So this talk is going to be about these 2 things. So Terraform AWS modules is a collection of reusable components for common AWS services. And currently we have more than 50 of them. Which means that all kind of VPC, ECS, EKS, and so on is all well supported. And there are a lot of users of these modules, so the community is pretty big. And there are a lot of features covered. Everything is shown with examples and so on. I live pretty much from support. I don't have full-time job, because I don't have time for that. Most of the time I write something in the open source, publish it, and then companies who like what I do, then they either hire me to do some extra work or to explain how things can be improved in their company. So that's pretty much what I do. So the talk itself starts now. Okay, let's talk about serverless architecture and figure out what is it and how Terraform can be used for that one. So a sample serverless architecture is really simple. Like on this diagram, we can see that we have an API gateway, a couple Lambda function, some DynamoDB, some CloudWatch, nothing really fancy. So the request comes to an API gateway, and then several services are being called. The important part here is that serverless architecture suppose developers to focus significantly more on just writing application code, and in this case, it is Lambda. So we need to focus on writing application code, put it somewhere in the Lambda service, and let AWS let's use the rest of the AWS services like API Gateway, DynamoDB to achieve what we want. If we look into this from another perspective, we already have pretty good, I'm speaking about we because that's what community is using. Community is using Terraform and community have been using Terraform for quite some time to manage RDS, VPC, IAM, and so on. So it would be a pretty natural choice to use Terraform to manage also serverless resources like API Gateway, DynamoDB databases, and so on. And I believe that Terraform is also a very good option to manage both infrastructure and application code. So if we look into what kind of available options developers normally have, well, first option is quite straightforward. AWS has serverless application model, or SAM, or you probably have heard about serverless framework, because for many people it is default choice still, because it has word serverless in the name, so probably it is serverless, so why not? Yes, it is serverless, but there are also other options. And then if we look into another group of available options which we need to interact with is so-called infrastructure management tools, Terraform, CloudFormation, CDK, or so on. And then we look into another group of things, which is deployment scripts, typically some shell scripts or make files, or we can use different services like code deploy, or we can script everything ourselves using AWS CLI. Ultimately, all we want to do is we want to instruct how to deploy our application to certain services. How we do this is not really important. And of course, as you probably know this term already, yak shaving is where you will spend a lot of time. Like a lot of time you will be dealing with something what you don't want to be dealing with, but that's the reality of our work. Otherwise, we wouldn't have work, right? We need to do something what other people didn't do for us, so we need to learn their job in order to be effective. I'm speaking from my experience because when I interact with something what I have not been using before, and I need to extend it in some level, I suddenly have to become JavaScript guru. I don't want to be. And that's exactly what is yak shaving and rabbit holes, where you can start doing something and you go deeper, 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 and then, oh my God, it's end of the day, right? We all know this feeling where you did, what did you do today? Not much. So that's, and obviously typical problems and challenges are quite easy to grasp. We have a lot of different overlapping solutions where you can talk to some group of people and they say like, oh yeah, you can write everything in shell. Okay, thank you very much, but it was not really what I was asking for. Or some CloudFormation fans will simply say like, oh yeah, I have 20,000 lines of code in CloudFormation, which does exactly like this. You just need to change it a little bit somewhere, and then they lost me again. So there are a lot of accidental complexity with pretty much everything what we have right now. And if we look into alternatives for this, the way I look at is that we try to have separation between if it is application code, then we use specifics for programming languages, like we use tooling we are comfortable to deal with, depending on which programming language we are writing, and given absolutely the rest to Terraform. I will explain what exactly absolutely rest a bit later. But think about this is that you as a developer of your application already have pretty good understanding, or hopefully have good understanding of how your code should work, what kind of functionality you want to have. So you focus on that side as much as possible and leave the rest of provisioning, deployment, updating, and so on to Terraform. And if we figure out that we want to fight accidental complexity and we don't want to look into something what is not moving us forward, we really need to focus on just writing application code, package it somehow, and that's it. We always need to try to avoid going into internals until it's absolutely necessary. This is partially why Terraform AWS modules are being used quite widely, is because you can get productive right away. You don't need to know why there are a lot of Terraform magic inside of some of them, or why there are a lot of type conversion happening. All you need to do is just to get your job done. You look into your kind of entrance point, and you figure out what's happening there. If you need to submit patch, or you need to figure out why this was implemented, then of course it's open source. You look deeper, and you can spend a lot of time studying it. But to get rid of accidental complexity, you need to just focus on what you really need to do, which is your application code. And yeah, you can think that everything can be implemented in a mix of different tools. For example, there is already a pretty good pattern where people say like, oh, this is serverless resource, so we need to use our serverless tooling for that. Or there is VPC or IAM roles or RDS database, so that's why we use Terraform for. And then I usually ask questions, okay, what if we have something in between, like IAM role? IAM role can be used inside of your serverless applications, and it has a lot of relation to serverless as well as not serverless. So where to put these IAM roles? To serverless frameworks or similar tools, or to Terraform? And my preferred way is quite obvious. I mean, we all put most of things in Terraform anyway. What is not in Terraform is just application code. So this is how serverless TF started. I was thinking that if we look into common patterns and common tasks which we need to deal with when we are implementing serverless architectures on AWS, we need to build them somehow, we need to deploy it somehow, we need to manage different properties, and so on. So that's how all of these modules were created over the time. All of this is open source and available for usage right away. There are no hidden things whatsoever. And if I look into serverless TF highlights, you may think that serverless TF is like framework. Well, it is framework by definition, but it's not a CLI. It's more like a collection of patterns which you can use together, or which you can implement together, and you will be able to provision and to manage your serverless infrastructure on AWS. So it is absolutely decoupled, and all of these modules are very specific. They have zero dependencies between themselves. You can easily replace one with another. You can always fork whatever you want and use your own fork if that's what you want to prefer, instead of having your private life, but okay. So yeah, it's fully open source. So yeah, I have some time. If you want to see a demo, well, I have, no, that's not my laptop. Okay, so no demo. Yeah, well, I have screenshots at least. The demo is available here, but I have some screenshots where I can show exactly the same things as I would show on my laptop. So the key thing here, if I look into this diagram, the key here is write and scan Lambda. So these two Lambda functions created using Terraform, and this is the configuration how we can do it. So if we look into the source, we are calling a Lambda module which is part of Terraform AWS modules. So serverless TF is not an independent thing. It is a set of pattern explaining how to use Terraform AWS modules to work with serverless on AWS. That's it. There is no CLI. As somebody opened issue recently and say like, oh, serverless TF is dead. because there are no commits for the last 3 years. Well, look into another repository, that's it. The set of patterns has not changed so much. I mean, you just use whatever you find and connect them in certain ways, and I described in which exactly way on serverless.tf. So when you want to provision Lambda function, all you need to do is just to call this Lambda module of specific version and specify several parameters. Some of them are required. Most of them are optional. When I say that we develop Terraform AWS modules for serverless, it means we develop them for a very wide variety of features and capabilities. And this is, as we all know, AWS is always adding new stuff into their services, then these new features being available through Terraform AWS provider. And then we think about how these things can be used together, and we update it into Terraform AWS modules. For example, one of the recent live stream which I had, where I spent in total more than 10 hours to add support to event bridge pipes. Sounds very kind of straightforward, right? But in fact, it's extremely complicated. I made it live, so you can go to my live stream and see last live streams where I was explaining my thought process, which actually was broken in the middle, but anyway, it was still my thought process. Yeah, hopefully you can learn how internal stuff is made. But going back to this example, we can specify required parameters like function name and a traditional set of things. And we also specify a set of arguments required or describing how this has to be packaged or whether we want to build a package at all. So when we are specifying that we want to use, let's say, S3 existing package, as you can see here, I'm specifying that my CI or my other script has already packaged this Lambda function, and it is already available inside of my bucket with name fixtures. Yeah, I was so happy to get this bucket name on S3. I mean, fixtures. I thought it's already taken, but then AWS gave it to me, so now it is a real bucket where I store my fixtures. Yeah, that's my achievement. Okay, and also as part of Lambda services, you may think that you need to build package and you need to specify a lot of different triggers and asynchronous invocation and a bunch of different policies related to that. All of this you can, all of things which you can see inside of AWS console when you go to edit this function, all of this is part of AWS module, which I'm using here. So think about it as you call one module and provide hundreds, I mean, of course, not hundreds, but 20, 30 different parameters required for your function to operate. So it is very simple and very easy to understand the relation and the configuration, because it's all pretty much in one file across 20, 30 lines of code. There are no many places you need to go and to see like, oh, this is fetched from here, this parameter is overwritten there, and so on. It's all one module being called with certain parameters. Like here, if I need to specify that my DynamoDB table will have to be accessed from this Lambda function, all I need to specify is just to add new policy statement to allow DynamoDB get item from that table. That's pretty much it. And if I look into another example here, which is an API gateway, I'm calling another module to make API gateway, and I specify different type of integrations which has to happen here. So if there is GET request, then I send a request to one function. If it's POST request, then I send to another function. This is a simple example. But you can imagine that by looking into your small configuration files, you will be able to understand pretty much everything what you need to know, and you will be able to understand what kind of implications will happen if you change something here, because that's how Terraform works. If you run Terraform plan, it will understand the whole dependency graph right away. And even more, if you use Terraform AWS module to build your Lambda function, and you change something inside of your source code, then you run Terraform plan, and Terraform plan will calculate and will tell, like, oh, I see that you change your source code or your package JSON or requirements TXT, whatever. Then it will understand that it first has to package this stuff or build your dependencies, package it somehow, upload to S3, update Lambda function, update permissions, update triggers, update this, and that's exactly the job of Terraform. And that's why we like this approach instead of us scripting it in traditional makefile or shell script or whatever else. So that's the point of using Terraform to handle and to resolve all of these dependencies. Similar, very small example for DynamoDB table, quite obviously easy to understand that we're making table with a random name and we provide some attributes. So all of these things may look simple, but inside of this module there are usually, I cannot say 100% because maybe AWS released something while I'm speaking here, but usually it's like close to 100% of features. So in DynamoDB, for example, you can specify that you want to have auto-scaling or scheduled, whatever kind of feature they have. Yeah. So looking into different features of Lambda module, which is like the core of interacting with AWS Lambda service, there are very many options how you can build your application. One of the common pattern which we interact with, if we have M1 Mac, for example, and we need to build it to build something what will be running on another architecture, we can build it in Docker. We can provide many different Docker arguments. We can access private Git repositories by dealing with SSH agent inside of Docker. We have a lot of shortcuts for different frameworks and languages like pip, poetry, and npm is something what we support quite natively, which means that we'll be able to understand that this code is written in Python, so we need to run these commands. As always, everything is parameterized, and you can see everything in example. And this is, again, the point of open source modules, is that you don't need to just blindly guess what's happening. If there is a feature, then there is very big probability that we cover it in example. Because in Terraform AWS modules, we don't have any other ways of testing than examples and relying on community. So if I made a mistake, I updated an example. If I didn't think about something else, then I push it into master, and then I expect people who don't pin version to complain in half hour. That's the reality. I mean, feel free to become beta testers and open issue very quickly. I know there are a lot of people who don't pin versions for different reasons, and then they say like, oh, you broke my production. Well, thank you for being beta tester. Yes. And also there are several ways where we can, or what can we do with packaging of an artifact. We can put it into the pipeline where we build our Lambda function the way we want, and then we store it inside of S3, and then we just specify it as a reference to the Lambda function. Or we can use Terraform to build everything for us. This is still an option. And when it comes to deployment, there are so many different options where we can think about how we want to implement the deployment strategy. The simplest one is that as soon as code is changed, then it's automatically latest, and then it's automatically deployed. Or we can use some control deployment using AWS Code Deploy and implement any type of strategy supported by it. For example, rolling deployment or canary deployment and so on. And yeah, as always, you can always switch any Terraform module you want. You can integrate them the way you want. They have zero dependencies between themselves. And yeah, one of the the point is that if you have your CI/CD process for any other software which you develop or anything what you use to package to validate quality of your application, you can reuse exactly the same process, but your artifact will have to be stored somewhere, let's say in S3, and then you just use the same commands, Terraform init, plan, apply, to update that Lambda function. And I think that's it from me. I still have time for questions, and yeah.